Hello, General Chemistry. We're going to discuss electronegativity today. Electronegativity is the ability for atoms to pull electrons. And all atoms have electronegativity except the noble gases. And that's because the noble gases, they don't pull on electrons. They don't react. They don't interact. They don't have electron transfers. They don't become ions. They don't do all of these things that electronegativity causes. They don't react. But lots of other things do react, and they react because of their electronegativity. So pulling on electrons is kind of a big deal because it is responsible for why all of the atoms rearrange to make new molecules so that we can have all of the different types of substances that we have on Earth and in the universe. So, what is electronegativity? Well, it's the ability for an atom to pull electrons. If an atom has a very high electronegativity, that means it pulls electrons very strongly. And if it has a low electronegativity, that means it is very weak with its pull of electrons. And it turns out that atoms with high electronegativity can pull atoms away from atoms with low electronegativity. So let's take a look at some of the patterns with electronegativity. Electronegativity is the balance between two things. One, the number of protons that an atom has, because protons pull on electrons. And two, the number of electron shells an atom has, because those electron shells increase the space between the protons and any new electrons that they're trying to pull, and those proton shells repel new electrons that are trying to come in. So the more electron shells you have, the lower your electronegativity. And that's what we see on the periodic table. In this model, the taller the element, the more electronegative it is. And so we can see that as we go across, as we add protons, the electronegativity gets higher because protons are pulling harder on more electrons. But as we add electron shells, because each row is a new electron shell, as we add electron shells, the electronegativity goes lower because it's harder to pull through all of those new electron shells. So as we add protons and go across, electronegativity goes up. As we add shells and go down, electronegativity goes down. Well, there's one more thing about electronegativity, and that has to do with the valence electrons. Valence means outermost. So you can have outermost shells or outermost electrons. Both of those would be your valence shells or your valence electrons. Let me find this. Sorry, guys. There we go. Now, so as we said again, valence is the outermost shell of electrons, or your outermost electrons. Here's the big deal with valence electrons and electronegativity. It's the Octet Rule. We said earlier that atoms with a high electronegativity can steal electrons from atoms with a low electronegativity. Well, that will continue. Electron transfer due to electronegativity stops when an atom has a full valence shell. So electrons will continue to steal from each other until they get a full shell of valence electrons, and then they will stop because the atom can no longer pull more to it after it adds another electron shell. So that's it for electronegativity. I know that was a lot to throw at you in one video. We're going to review this stuff some more in more detail when we go over our next video, which will be ions. I hope this helps. Struggle well.